All right, so number 9 says, let me get comfortable here. So it says compound C has infrared absorption in the 1620 to 1680 reciprocal centimeters range, and in the 3590 to 3650 negative reciprocal centimeters region. So it says draw the R and S enantiomers of product C. So here's the molecule they give us. This molecule is called Cis-4-Bromocyclohexanol. And according to the Cahn-Ingold-Prelog system, that's the naming system, the OH group is R because that's where you start, that's where the 1 is, and then you move in the direction of the next, the highest, the atom with, this atom's attached to a bromine, which has the highest, I think it has to do with the molecular weight of the ion. Bromine has higher molecular weight. So I had to go clockwise to get there. That's the fastest way to get there, clockwise, so it's R. And the bromine, this carbon has the highest value group because it has an oxygen. You know, this has H and this has H, and the quickest way to go there is by going, if I went this way, I'd go 1, 2, 3. This way I go 1, 2, 3, 4. Oh no, okay. So actually, that's R, and then this is R2, because the quickest way for me to get there is to go this way, and that's R. So the bromine is R and the OH is R. I'm treating this with tert butoxide and tert butyl alcohol, and I get a racemic form of C6H10O, and that is compound C. So racemic means that I'm getting 2 optically active enantiomers in equal amounts and quantities. So what we need to know is that having a bulky base with a cyclohexane molecule, cyclohexane ring, is going to lead to an E1 reaction, an E1 elimination. The IR, which is 3590 to 3650 negative reciprocal centimeters, that's like a phenyl alcohol, an alcohol connected to a benzene ring or a cyclohexene ring, maybe with a double bond on it. And C20, 1620 to 1680 reciprocal centimeters equals an alkyne double bond. So here we have the E1 mechanism. So first what's going to happen, we have the molecule here. And it's in tert-butyl alcohol. This is a this is second degree carbon. And the bromine easily leaves in the protic solvent. It leaves, and we get left with this second degree carbocation. Now that's the most likely thing to happen because the tert-butyl alcohol is whatever. Never mind, I'm not going to get into that. So this is what we're left with, right? Then what happens is the tert-butoxide base, the strong hindered base, is going to come in and pluck off an alpha hydrogen, a neighboring hydrogen. And it has two routes that it can do that by. It can go by route A, or it can go by route B. Right? So if it goes by A, it's going to take this hydrogen, the double bond will be pushed there. And if it goes by this route B, it's going to take this hydrogen, and the double bond will be put there. So by route A, we get the following molecule. OH is coming out, the H is going back. The quickest way, so we start at OH, the quickest way to get to the highest, a double bond is higher. The Cahn-Ingold-Prelog system has rules about which way to go to get to the highest part of the compound, and I'm not using the right language right now, but in order to get there, the quickest way is to go counterclockwise. So this is the S molecule. And then by the B route of the mechanism, we get this molecule. And the quickest way to get there is to go clockwise. So this is R. And that's how it works.